So in this lesson, we're actually looking at translators. Basically, we need to know, how do we go from Python to binary? Think about all the programming languages you know. None of them are written in ones and zeros. Whether it's Python, Logo, C Sharp, SQL, HTML, XML, none of them are written in zeros and ones. Machine code, well, is zeros and ones. When computers were first invented in the 1940s, well, they have to be programmed, right? But they could only be programmed using zeros and ones, ons and offs. Instructions were written in binary, so typical instructions would look like that. You would have to sit there and write it and know what each one of those ones and zeros meant. Each instruction did a very small task, like load the value 1 into the accumulator. That's what that instruction is. Writing programs was, well, suffice to say, difficult and very time consuming. And then came along assembly language. Now, assembly language is directly translatable to machine code, right? It allows programmers to create programs that are more easily written in uh, than machine code, but each assembly language instruction maps directly to machine code, right? So when it's translating, each line of assembly language is a line of binary. For example, assembly language on the left hand side, like LDA51, which is load memory address 51, and add, and then you've got their hexadecimal FF to it, so that's 255 to it, and then store it in memory address 52, right? Would be these in binary, but you are quite literally just one line of binary at a time. Assembly languages are processor specific, so it has to be translated into machine code before it can be executed. As each instruction corresponds directly to machine code instruction, it is still known as a low level language. So there are two low level languages: assembly language and machine code. Higher level languages, thankfully, is where we don't need to write in insane language and we can talk more in maths and English. Writing in high level languages makes it easier to learn, makes it easier to read as well. It also means that we can do more complex things like have arrays or write to files and stuff. But because we're writing such complicated things, a single statement usually translates into several lines of machine code instructions. The translation is done by a program which may be either a compiler or an interpreter. So there are two ways that we can translate our high level languages to machine code. Remember that our high level languages need to be translated using a compiler or an interpreter. So translating from that to that, either by compiling or by interpreting. We're going to go over what those two mean now. But assembly languages still need translating too, but less so. They are still a low level language. So, what are the advantages of writing in a high level language? Well, loads of advantages. Number one, they're easier to learn. Number two, we can write them faster, easier to understand and debug as well. Why do you think that low level language is still used by some programmers? Well, number one, programs written in a low level language can run very quickly because there's less need for translation. The code will usually require less RAM because, again, less need for translation. Statements in a low level language can be used to control and manipulate specific hardware components too. So if you want to speak to your hardware directly, you need to be writing in assembly language or machine code itself. So what does a compiler do? Well, a compiler translates a whole program all in one and then creates source code. Basically, if you've got a program that adds two numbers together, it doesn't really matter what it is, what the program is. It will translate all of it in one go and then create an exe file, uh, which is then directly accessible, directly executable, sorry, by the CPU. The code produced by the compiler is called the object code. There we go. The object code can be saved in a storage drive where it can run whenever it's required. Sorry, that was a bit blocky because there was someone at my door. Anyway, going to move on. So the object code can be run like without translating afterwards because it's already been translated, which is why all the programs that you've then installed are just installed as exe files because they can then just run really, really quickly because they don't need to be translated again. An interpreter, on the other hand, doesn't do things all at once. It translates lines of code one line at a time and executes it immediately. That's what we do when we create Python, which is why sometimes we get the outputs for the top of our code, and if there's a syntax error, near the end of our code, that's when it will stop. It's because it's translating each one of those lines in sequence, in order, and then just does it. And then when it gets to a problem, it will stop. So compilers translate the whole program to produce an object code, whereas interpreters translate one line at a time. A compiler uh, a compiled program executes faster as it's already in machine code because we've got that exe file. An interpreter takes more time to execute as each instruction is translated before it's executed. And you've got to do it every time. We don't create an exe file at the end. It just runs and does that translation every time you run it. There's no need for the compiler to be present when the object code is run, but the interpreter must be installed to run the program because we're translating it every time we run it. Customers who have bought commercial software cannot see the code when they buy it, so they cannot adapt it. But in the other one, where we're using interpreter, customers can see the source code, so could potentially adapt it to see how it works. So compiler or interpreter? Well, pretty much just depends on what you're doing.